If we now have a look at question 2, this is now where things become a little bit more complicated, or we need to think a little harder, because now what I see is that I've got x's on both sides of my equation, and we need to think about what that means. Okay, so sorry, I just need to take my jacket off because now I can't move my arms properly. Chaos. Okay. When we have a variable, and the variable can be anything, in this case it's x, when we have variables on both sides of the equal sign, our goal is to get all of the x's to one side and all of the numbers to the other side. So we get all x's to one side, or terms with a variable, and we get all numbers to the other side. Guys, numbers we could also call constants. Remember, they're just numbers without the variables. Alrighty, so that is what we need to bear in mind when we have the situation of variables on both sides. Now, grade 8, what's really important is it doesn't matter which side you choose to put your x's and which side you choose to put your numbers. For the most part, if we go back to this first question, for the most part, we generally have x on the left equals and then some value. So throughout all of our examples, I'm always going to put x on the left, but it doesn't matter if you put it on the right. You will get exactly the same answer if you do your inverse operations correctly. So as long as you do all of the inverse operations correctly, which side you put x on makes no difference. Okay, so if we now have a look at the second question, we can see that we've got x terms on both the left and the right-hand side, as well as constant terms on both the left and the right-hand side. So like I say, in all of our examples, I'm always going to choose to put x on the left so that we always have x equals. And so essentially what that means is I need to take this positive 2x and I need to bring it over my equal sign. Because that is what I'm doing, what I need to remember is I need to now use my inverse operations. So if I want to get rid of the 2x on the right, I would have to subtract it. But then I need to do the same thing on the left. So let's start filling this in. We'll have 3x. We're bringing the 2x over, so it becomes minus 2x. We still have the minus 10 there. We'll sort that out in a second. Is equal to the 2x. Remember, we subtracted 2x. And then we've got that plus 10. So through our inverse operations, what we've been able to do, as you can see, is we've been able to get rid of the 2x on the right, but we've brought it back on the left-hand side. So we haven't gotten rid of it. We've just moved its position in the equation. The next thing I'm going to have to deal with, because now I've decided to put all of my x's on the left-hand side, the next thing I have to deal with is getting this negative 10 over to the right-hand side. And again, we use inverse operations. What that's going to then mean is that on the left-hand side, I still have my 3x minus 2x. But now what I'm going to do is I'm going to add 10 on both sides in order to bring the 10 over. Now, we've already discussed that the 2x's cancel, so I've got no x terms on the right. But I do have the 10 still, and what I do on one side of my equation, I need to do on the other side. What this now means when I simplify this all is that I've got my 3x and my minus 2x on the left. Remember, the negative 10 and the positive 10 become 0, but the 10 is brought over to the right. And so I've got 3x minus 2x is equal to 10 plus 10. Now be careful, guys, when you subtract, you are subtracting your like terms, so you do need to make sure that you are doing it correctly. 3x minus 2x is equal to just positive 1x. You can put the 1 there if you want, it doesn't matter. And that is then equal to 10 plus 10, which is 20. I've isolated, I've gotten x alone, I've solved for x. And so this is my final answer. So guys, please remember, some of you are not using inverse operations or not using them or forgetting to use them. Please remember, you have to use your inverse operations in order to solve correctly. When or if, sorry, I'm trying to reply to questions. If you want to check your answer, remember you can. You can take this value for x that you have now just solved for, and you can substitute it back into your original equation and make sure that both sides are equal to each other. So if we just do a quick little check for ourselves to make sure that we have gotten the correct answer here, what we would do, I'm just going to do it in a little block, is like I say, we would substitute. So guys, you don't have to do this check. This is for yourself. We would now say 3 times 20 minus 10 is equal to 2 times 20 plus 10. 3 times 20 is 60. 60 minus 10, whoops, is 50. On the right, 2 times 20 is 40 plus 10 is 50. And because my left-hand side is equal to my right-hand side, I know that my answer is correct. Alrighty, so very importantly with equations is your inverse operations or your opposite operations, as well as remembering that if you are not sure, you can use substitution to check. Right, so I'm just going to do this so that you can take screenshots of both of those. If you have questions, now is the time to raise your hand.
I hope you also took screenshot, my people. This was a nice explanation. We have both questions there, then just snap a screenshot. And I'm sure the next one is them. Hey, the next one, they need to be doing it. Hey, Teacher Sham, them.
Well, yeah, we'll see.
I hope they're doing the next question. Sorry, I think my network is just bad today. Sean Maluleke, you have a question on your side? Oh, Sean has it, it's gone. Okay, Abigail, you want to ask something?
Yes, I wanted to ask the x. If you take like the two x's, do you like put them together?
I'm not too sure what you mean.
Wait. What I mean is, if you were to maybe like take the other x, so if one side has an x, you put it at the another to the other one.
Yes, you essentially have to group your like terms together on each side of the equation.
Oh, okay, that's my question. Thank you.
Okay, so guys, that's actually a really nice way of thinking about it. For equations, you essentially want to group your like terms together. So all your x terms go to one side of your equation, all of your constants go to the other side of the equation. You're grouping your like terms. Okay, I'm not too sure why you want me to go lower. Everything is there, but there you go, just in case. Sean, question?
Oh, ma'am, I was asking, how did you get the 10s?
The 10s came from the original equation, remember? So if we have a look, there are the two 10s in the equation. And so what I wanted to do is I wanted to bring this negative 10 over to join the positive 10, which is why it then became plus 10 on the right-hand side.
Okay, thank you, ma'am.
Okay, cool. Tebogo?
Ma'am, can you hear me?
I can.
Ma'am, for question 1, I wanted to ask, shouldn't the -3 be a positive since we're doing the inverse operation?
Remember, I didn't move that 3 at all. It stayed on the right-hand side the whole time. So because I didn't move it at all, it doesn't change its sign. Signs only change when we move it over the equal sign.
Oh, thank you, ma'am.
Okay, so guys, that's really important to remember. The only time we change signs is when we're moving over the equal sign. All right, so when we're grouping those like terms on either side. Bakang, I'm not too sure what you mean. Doesn't it add an exponent? No, remember exponents only change when we're multiplying or dividing. I'm not doing that here. I'm adding and subtracting. Yeah, guys, we've just started. There's not a chance that a brain break is happening right now. All right, so again, when we have got variables on both sides, we want to essentially group our like terms. That means that we need to bring all the x's to one side and all the constants to the other side. So let's have a look at question 3 here. I don't think we're quite feeling confident yet to try it by ourselves, so let's do this one together, and then we will, or you will try one by yourselves. So I'm going to simplify this a bit because obviously this was quite a lot of writing that we had going on here in question 2. So let's see what we need to do here. First thing I see is that I've got x's on both sides. So what I want to do is I want to bring this, 7x. I want to bring this 7x over to the left, which means I will have to use an inverse operation because I'm moving it. And then the next thing I want to do is take this plus 3 over to the right. Now, guys, this is like how I'm about to write it now is more like your English. Okay, I'm going to start that sentence again. The way I'm going to write this now, if you would prefer to write it like this and shorten all of those inverse operations a bit, that's fine. Okay. So basically what's happening is because I'm leaving the 9x exactly where it is, it stays positive 9x. I'm bringing the 7x over, so this becomes minus 7x. All of my x's on the left, so I'm happy. On the right-hand side, 13 stays where it is. I haven't moved it. It's staying there. But I'm bringing that positive 3 over, so it becomes negative 3. So if you would prefer to write your working out like this, that is absolutely fine as well, as long as you are showing the inverse operations. If you don't understand where I got this, let's just take a step back and make sure that we all get it. 9x we're fine with, but what we need to do is we need to bring that 7x over. So what's going to happen is we're going to have minus 7x on both sides so that, let's hope I can fit all of this in, so that my inverse operations are accurate. The next thing I'm not a huge fan of is the plus 3. So I'm going to have to subtract 3 on both sides of my equation. Didn't fit. Right, so that now means on the right-hand side, I've got 7x minus the 7x, because remember, I wanted to bring it over, plus the 13, and because I minus 3 on the left-hand side, I need to subtract 3 on the right-hand side. What we can see now is that the plus 3 minus 3 becomes 0, as well as the 7x minus 7x becomes 0. And so that's how I'm getting 9x minus 7x equals 13 minus 3. Now you've got these like terms on both sides. And because we've got like terms on both sides, it means that we can add and subtract. So 9x minus 7x is 2x. 13 minus 3 is 10. Now again, grade 8s, the goal is to get this x all by itself. We don't like the 2 in front. What you need to remember is that anytime there's a coefficient, this is saying 2 times the variable, or the coefficient times the variable. So again, we need to use inverse operations. The opposite of multiplication is division. So I need to divide by 2. But if I do that to one side of my equation, I also need to do it to the other side of my equation. We know that 2 divided by 2 gives us that 1x that we wanted. And then we've got 10 divided by 2, which gives us 5. And so we found our solution for x. Again, if you want to check yourself, what you need to do is you need to go and substitute into the original question and make sure that both sides are equal to each other. Right, so take your screenshots. If you have questions, now's the time to raise your hand and ask. But the really important thing here, guys, inverse operations. See you, so?
Hi, ma'am.
Hi.
I just wanted to ask, when do the sign change? Because my teacher told us that when there's signs both sides, we change the signs.
Okay, so remember, signs only change when you move it over the equal sign. So here, what we did, we took this 7x and we moved it over. That's why it became negative 7x. We took this positive 3 and we moved it over. That's why it became negative 3. So signs only change when you move their position over the equal sign.
Oh, okay. Thank
Okay,
you.
good. Right, guys, so you're going to try the next one by yourselves. I'm hoping we've all taken screenshots. Okay, I'm going to change this next one. Oh, sorry. Yeah. Okay, right, I want you to try. Nothing is working. Sorry, guys, I don't know what's happening. Right, I want you to try question 4 by yourselves. I just don't want to give you anything too mean, so let's change that to a +4. Okay. So I want you to try question 4. What I'm going to do is I'm going to make that a bit smaller so you can see exactly what we did in question 3. And I want you to apply that same method to question 4 here. So question 4, minus 3x plus 4 is equal to 3x minus 8. Remember those inverse operations. And remember, like I've just said, we only change signs when we move it over the equal sign. That is the only time that pluses become minuses and minuses become pluses. That's it. Right, so give this a try. Remember, if you're feeling stuck, ask your questions on the chat and we'll help you. Exactly like Sibuneso did there on the chat. Once you've got an answer, put your answer on the chat so we can see. Let's see if we all agree.
Let's go, my people. We can do this. We are doing it. Well done, guys. You're doing great.
Sipilele, remember we get 5 because we have to divide both sides by 2. So the 2x needs to be divided by 2 to get the x alone. And then we also have to divide the 10 by 2 because if we divide one side, we have to divide the other side. And so 10 divided by 2 gave us our answer of 5. Grade 8, we need to check our maths here. I can tell you now it's not 12. I know where you're getting 12 from, and so you're on the right track, but it's not 12, no. If you're not sure of your answer, use the check. Go and substitute in both sides and make sure that the left-hand side is equal to the right-hand side. That is how you check your answers for equations, grade 8s. So use substitution and see if your sides are equal. If they aren't, then no, the answer is not right. If they are equal, then yes, your answer is correct. Right, let's have a look. So what we have here is, again, we've got x's on both sides. So what we want to do is we want to take this positive 3x and bring it over. So that would make it a minus 3x. And what we also want to do is we want to take this positive 4 and we want to bring it over our equal sign. So inverse operations means it becomes minus 4. Right, so if we write that all down for ourselves, we will have minus 3x minus 3x on the left, because I've brought all the x's to the left. And on the right, I will have my minus 8 minus 4. Remember, the minus 8 and the minus 3x haven't gone anywhere. It's only the plus 4 and the 3x that I'm moving. Those are the only ones whose signs change. So on the left, minus 3x is negative 6x, and minus 8 minus 4 is minus 12. Right, now again, we don't want that negative 6 attached to the x, so we need to use our inverse operations, because remember, this is negative 6 times x. The opposite of times is multiplication. But if I divide the left by negative 6, I also need to divide the right by negative 6. Now remember, negative 6 divided by negative 6 essentially cancel. They give us 1. So we're left with that x that we want. And now on the right-hand side, a negative divided by a negative is positive, and 12 divided by 6 is 2. And so we've solved, getting that x is equal to positive 2. So just a reminder, guys, a negative divided by a negative is a positive. Right, take your screenshots. If you have any questions, you can raise your hand. And remember, of course, grade 8, our goal, the end goal, is to get that x alone. I shouldn't have any other numbers by the x. I should always end positive 1x equals some value. Okay, you're taking screenshots? And again, remember, if you want to check, you substitute in. That is how you will know if your answer is correct. All right, brain break time. So you've got your puzzle here that you're needing to find the final answer for. So this final equation here at the bottom, I want to know what is its value. We'll wait for you to put it on the chat. First, once you get it right, we'll explain it. I need to quickly do it. Oh, you guys are fast tonight.
They are killing it, and their skills. Hey guys, you need your algebra skills. What we are doing is really going to help you to solve this one.
Ugh.
How does a mathematics class feel with a protractor? I hope y'all got that. Well done to Litabo. Litabo is the first one to get it right. Well
Oh,
done, Litabo. Do you want to
nice.
come and explain to us? Well done, Litabo. And well done to everyone else who gets it. Litabo, do you want to raise your hand so we can ask you how you got it? Well done. You were the first person to get it. I'm glad, Andile, you're laughing because of the joke, right? Okay, Litabo is, yeah, Litabo, I'm unmuting you. There we go. You can take us through.
Okay, so I first started by checking the Pikachus, which I saw. I divided by 3, which is 6. So the Pikachus are equal to 6. I checked the other Pokemon and I saw the second ones were 3 because I divided the 9 by 3,
Good.
which gave me the value. And then I saw the other Pokemon and its value was 3 times 3 minus 3.
Good.
So I just added all of them. I just times the Pikachu by the other Pokemon, which gave me 18, and I minused it by 3, which gave me the answer 15.
Excellent. Well done. And guys, what Latabo said there at the end, 6 times 3 first because of BODMAS. Okay, so Latabo beautifully followed our order of work that we needed to do. Latabo, excellent. Well done. That was so quick. All right, so guys, remember BODMAS. So even in the one before, you first had to do the 3 times 3 and then the subtraction. 3 times 3 is 9. 9 minus 3 is 6. So that's why we got each of those, whatever they are, as 3. Right, very nicely done. Okay, so sorry, I was scrolling the wrong way. So let's have a look at our next set of examples here where we now have some fractions. Okay, now guys, fractions are nothing to be scared of. As long as you remember your inverse operations, you will be fine. So here we've got 3x divided by 4 equals 6. Okay, so when we have a fraction, the first thing we want to actually try and do is get rid of that fraction. Because like I say, fractions aren't scary, but if we can get rid of them nice and early, it makes our lives easier. So what we need to remember is that this fraction means division. So this section here means a division by 4. We have to use the inverse operation. So what we're going to have to do is we're going to have to multiply by 4. So I'm just going to rewrite this question so I've got a little bit more space here. If I now go and multiply this term by 4, so technically I've got 4 over 1 because that's how we would write 4 as a fraction. What we see is that the 4's actually cancel each other out. And so what I would be left with on the left-hand side is actually just the 3x. So I'm getting closer and closer to getting x alone. But remember, of course, guys, if you times by 4 on the left, you also need to times by 4 on the right. And so we have 3x is equal to 24. If you are not timesing by the same value, you are not working with the same equation anymore. You're changing the entire meaning, and so you're now working with something completely different. So now we've got that 3x equals 24. The goal is to get that x alone. I don't like the coefficient of 3, so I now need to use my inverse operation and divide by 3. Because we know 3 divided by 3 is 1, they essentially cancel. I can't just stop there though. I have to also divide the right-hand side by 3, because what we do on one side of the equation, we have to do on the other. And so x is equal to 24 divided by 3, which is 8. And so x is equal to 8. Now again, grade 8s, check yourself. So let's do a little check here quickly. Doesn't need such a big block, but whatever. 3 times 8 divided by 4 should give me 6. So 3 times 8 is 24 divided by 4. 24 divided by 4 is 6. Is 6 equal to 6? Yes, it is. And so my answer of x equals 8 is correct. So whenever in doubt, use your check. You don't have to show the check. You can just do it on a rough piece of paper or in pencil on the side. But if you're not sure, do your check. And again, remember your inverse operations. What we now need to remember with fractions is that the inverse of a fraction is to multiply. Right, so I'm going to stop there. If there's any questions, now's the time to raise your hand. Otherwise, we'll have a look at another one. Motale?
Greetings, ma'am.
Hello.
Ma'am, I wanted to ask, ma'am, if it's still fine if we can use the method, like let's say we take the 4 from underneath and transmit it that side, ma'am, to the 6 multiplier. Then it's gonna say 3x is equal to 6 times 4. Would it still work?
Yeah, that's absolutely fine. So you don't have to show the multiplication of 4 by the 3x. If you are bringing it over correctly and showing that you're timesing by 4, that's fine. Yeah, no problem.
Thank you, ma'am.
Sure. Right, Sean, I see your hand as well. Question? There we go.
Oh, ma'am, I was asking, how did you get the 4 over 1?
Okay, so remember, in the original question, I've got 3x divided by 4. So what that means is I need to get rid of that denominator of 4. I don't like this fraction situation. If I'm dividing by 4 originally, my inverse is to then times by 4. And that is why I'm multiplying by 4 here. You don't have to write 4 over 1. If you're more comfortable saying times 4 and then canceling them out, that's fine. But you are multiplying by 4 on both sides. Right, so guys, in answer then to the question of where did we get 1, please remember that any whole number or any integer can be written as a fraction over 1. You don't have to write the 1 there. That's absolutely fine. But 4 can be written as a fraction 4 over 1. You don't have to have it there. It's absolutely fine. You can just say 4. There's no problem. But yeah, any integer can be written as a fraction over 1. Akani? Oh, sorry. There we go.
Hello, ma'am. I just wanted to ask, how did you get the 8 again?
Okay, so the 8 has come from me saying 24 divided by 3. 24 divided by 3 is 8.
Okay, thank you, ma'am.
Sure. I feel like there's been a hand up and down, up and down. Just make sure that we're all okay. Koklano, no, it's not 1 over 4. 1 over 4 would not cancel out the 4. You times by 4 because you were dividing by 4. Okay, guys, we're not understanding.
Sorry, teacher Sam. It's me who was speaking while you're speaking. I was just trying to comment also and encourage them to say the opposite. And also they can refer to the previous videos also, because we also did this with teacher Jan on Monday. So you guys should be in the fast tracking of this thing. But yes, you can continue. Sorry.
No. So guys, that's exactly it. So like Yolanda says, it's the opposite. So the original, like I've said here, the original was dividing by 4. So the inverse is to times by 4. If you times by 1 over 4, you're not doing the inverse, okay? It's the same thing as if you originally had times 3, the inverse is to divide by 3. So just always think about the opposite operation. Right, if we're not understanding, like Yolanda says, please do go watch the video from Monday, but we are going to do another example. So please don't worry. I'm not going to do that example just yet. I'm going to, oh, look at that, question 2. Right, I'm just going to change this very quickly. Oh, stupid thing. Right, so let's have a look at question 2. So if you're feeling like you're not really understanding, I'm going to do this one with you, and then you're going to try one by yourself. Let's have a look at question 2. Okay, so I've got 4x divided by 5 equals 16. So again, I'm just going to give myself some space here. You don't have to rewrite it if you don't want to. Whoops. Atlachang, I'm assuming that was an oopsie on the chat. I hope we're not spamming the chat. All right, so guys, 4x divided by 5 equals 16. So I don't like that division by 5. So the opposite is to times by 5. That's going to get rid of the 5. It's gone. So now on the left-hand side, what I have is just the 4x. But remember, if I multiply by 5 on the left-hand side, I have to multiply by 5 on the right-hand side. You can't do it to one side and not to the other side. So now we've got 4x is equal to 16 times 5. If you can't do it in your head, that's okay. Just grab a calculator. But 16 times 5 is 80. Okay, right. Now that we've got that, remember, we want this x alone. So what we need to do is we need to get rid of that times 4. The opposite of times is to divide by 4. But I can't just do that on the left-hand side. I also have to divide the right-hand side by 4. Those 4s essentially fall away, leaving me with just that positive 1x. And 80 divided by 4, as a lot of you are saying, is rather 20. And so my value for x here is 20. Okay, so guys, when there's a fraction, what we need to remember to do is we need to essentially remember to times by the denominator so that we can get rid of the denominator. We don't want the denominator. We don't want fractions. It's not fun for anyone if we can avoid it. Okay, so take your screenshots and then you're going to try one by yourselves. Ooh, panic. Okay, I'm glad we're understanding. I'm just trying to think of something that's okay. Let's do. Kochalo, I'm not really sure why your hand's up because I haven't asked for hands, but yeah, what's wrong? Should be a pop-up to unmute yourself. There we go. What's your question? Okay, I'm not hearing anything. Try and type your question in the chat. Oh, is it just me? Okay. Right, guys, you are trying this one with the star here while I try and figure out what the sound issue is. Please try the one with the star.
I have muted. Sorry, I've muted. Hello was not muted.
Yeah, hello, just try put your question on the chat. I don't know, your audio is not really working so well. I think it's just internet. We're all lagging a little bit, so just try put your question on the chat for us. Guys, let's focus, please. Your responses and messages on the chat are answers only. That's it, all questions. So 5x over 2 equals 15. Right, so if we have a look, I'm not liking the fraction. I need to deal with that fraction situation. I'm dividing by 2, so that means that my opposite operation is to times by 2. That will get rid of the denominator. But if I do that on the left-hand side, I must do it on the right-hand side. So 5x is equal to 15 times 2, which is 30. I don't want that 5 there. I want x by itself. So I must divide by 5, but I need to do that on both sides. 5x divided by 5 leaves me with just that x that I want, and 30 divided by 5 leaves me with 6. So in this case, x is equal to 6, and I saw lots of x equals 6 coming through, so very nicely done, grade 8s. So take screenshots of those two if you haven't already. I would like to do one more before we end off. Alrighty. So let's have a look at this question 3. We're going to do it together. We've got 8 minus 2x divided by 4 equals 4. Now what's different here, guys, is all of a sudden you've got 2 terms in the numerator. But that shouldn't scare us. We still use inverse operations. So again, I don't like that denominator. Let's times both sides by 4 so that the 4 in the denominator is gone. What that means is I'm now left with the numerator that I had. So this numerator, 8 minus 2x, is all that is left on the left-hand side. So 8 minus 2x is equal to 4 times 4, which is 16. Now I solve my equation. I want to keep this negative 2x on the left, but what that means is I want to go and take this positive 8 and I want to move it over my equal sign. That means it's now going to become negative 8. So I'm going to have 16 minus 8 because it comes over the equal sign, so the sign changes. 16 minus 8 is 8. And then I need to get that x alone. So I don't like that times negative 2. So that means I'm going to divide both sides by negative 2. And that results in my x value of negative 4. Now guys, careful, it is negative 4 because a positive divided by a negative is equal to a negative. Be very, very careful of your signs here. Okay, so because it was positive 8 divided by negative 4, I've got a negative answer. Please remember, you should never have negative x equals. It is always positive x equals. And you should never have any number or anything attached to that x. It is always x by itself, positive x equals your value. So those of you writing negative x equals negative 4 on the chat there, guys, not negative x equals negative 4. It is positive x equals negative 4. Please, please bear that in mind. Always positive x. So take your screenshots. If you have questions, now's the time to ask. So again, grade 8, always make sure that x is positive. Positive x equals something. Sean?
Oh man, how did you like get the 8, man? Oh.
So the 8, remember, let's just do this quickly, sorry. The 8 came from the original question. So there's 8. Here's 8 in my numerator. I don't know what's happening, sorry. Oh. Okay, there's 8 in my numerator. Once I've times both sides by 4, I was left with 8 minus 2x. That 8 needs to come over the equal sign, which is why it became negative 8, because I wanted to bring it over to the right-hand side. And so then I was able to simplify. So the 8 comes from the original numerator of my question.